All of my new lessons are going to be interesting topics, for example, science or technology or art or economics or something that's actually like cool rather than boring stuff about cows and like people talking and who cares about that, man? Let's do something good. So here's lesson 18. This one's about natural plastics, also known as bioplastics. So here we go. Conventional plastic is an industry term used to describe synthetic organic materials. Now, synthetic means not natural, and organic means carbon, hydrogen bond, or something like that. It's organic chemistry, so just search that and you'll find all kinds of information well beyond the scope of this lesson. Organic materials. All conventional plastics today come from petroleum, also known as oil or gasoline, or well, oil and gasoline is different, but petroleum is usually referred to as oil, although in Britain they say petrol. I've got to fill my car with petrol. Sorry, I've got to take a tea break and fill my car with petrol. We call it gas in America. Gonna get some gas for my truck. Honey, I'm gonna go down to the store. Never mind. Okay, oil or natural gas can be used to produce plastics. Okay. Natural gas is methane. Check it out. Methane. Well, mostly methane. It's actually some other stuff too, but mostly natural gas is methane. Can be used to produce... Let's see, there's a mistake. Check that out. Can be used to produce plastics. All feedstock is heated under pressure, applied catalysts, and after a short period of time, plastic particles are produced. These particles are then sent to a processing facility where they are compressed under heat to produce the everyday items available at the store. Whoa! These blue chairs are an example of the everyday items available at the store. These chairs are the final product of a complex manufacturing process. These chairs are made in a big machine that just melts the plastic and it just shoots it in. Boom! And the chair is produced in, I think, maybe 3 minutes. And they just fall apart in a couple years, and then you throw it in the garbage dump, and it then gets converted back into methane gas, which is sometimes used to generate electricity, but that's a whole other story. Okay, let's go to the next slide. Bioplastic. Natural. As versus conventional plastic, which is unnatural. The problems with conventional plastic are numerous. Oil is scarce, refining of petroleum is toxic, and plastic garbage kills animals and litters the environment. The solution is to produce plastic from potato starch and glycerin. This material can be made at home because it is simple and non-toxic. Products made with these ingredients are malleable and biodegradable. The downside is that bioplastics have a shorter life expectancy. So basically, we've got problems, numerous problems, there's many problems with conventional oil-based plastic. We have scarce oil. There's not much available. There's very little oil left. Well, actually, there's actually a lot there. It's just too expensive to extract. And the refining of petroleum is toxic and produces all kinds of smoke. And the plastic garbage can, animals eat the plastic and they die. And it litters. Litter is just a word for putting garbage everywhere. Okay, the solution is to produce plastic from potato starch and glycerin, but this is just a homemade plastic. There's any factory that's making this plastic is not going to use potato starch and glycerin. They'll use a more probably from sugar. So here's something you could produce this credit card out of sugar, but it's a lot of processing. Credit and debit cards are easy to produce because the plastic material is malleable with heat. Yeah, I said malleable here. In 2 slides, I'll explain malleable. Malleable just means you can shape it differently. So here's the one is feedstock. The next what the hell? Where'd malleable go? Feedstock, catalyst. Well, there's malleable. Okay. So feedstock. Feedstock is the raw material or inputs to manufacturing processes. So here's our first example. The new organic feedstock is helping cows become healthy. That's one example of food for cows is called feedstock sometimes. Or they just say feed. Sometimes they'll say the animal feed, not necessarily feedstock. Although actually, the word stock means cow. From about 2,000 years ago, they called the stock market, right? Was the cow market where they would trade cows. So I suppose maybe feedstock means cow feed from a long time ago, but I don't know. The next example is feedstocks such as bamboo and hemp are environmentally friendly. And here you've got some kind of monkey guy with his bamboo. And the wood chips from the factory are the feedstock for electrical production. So if you take wood chips and you gasify them, is turn them into gas and then burn the gas in an engine, you can make some kind of electrical production out of that. So here's our monkey friend, and he's got his bamboo playground. Bamboo can be used as an industrial feedstock or a playground for wildlife. Catalyst. Catalyst is a chemical that increases the reaction speed without being consumed. Theoretically, in reality, the catalyst does get consumed because little bits get destroyed and they get sent through the factory and they go bye-bye, but theoretically it's not supposed to be consumed. Or a catalyst is an event that causes change. So here's the chemical example. The iron catalyst converts natural gas into diesel fuel. Here's another chemical example. The car has a new catalytic converter. And here's the event that causes change. Higher than expected profits were the catalyst behind the stock price move. That means something caused the stock price to move, or something caused change, It's like in Tunisia when the vegetable seller had his vegetables stolen by the government, and that was the catalyst for a revolution and the falling of the government. So there's 2 ways to use catalyst. Like, for example, conspiracy theories are often a catalyst for panic among people. For example, the 2012, people might be panicking and spending all of their money before 2012 because they think everybody is going to die. That's one way to use the word catalyst. Next example is refining. Refining means to remove impurities or to improve quality. So the impurities are just junk that you don't want in the product, or refining means to improve the quality. So for example, the iron is refined into steel tubing at the factory. That would be removing impurities and improving the quality. You're taking just iron, which is somewhat useless, and turning it into a very useful steel product. Refining olive oil produces a tasteless, odorless product. So if you don't like the taste of the extra virgin olive oil, you can have the refined olive oil. The singer refined her technique and she is now a successful artist. That's an example of that's an example of improving quality. Building a guitar requires refined technique. Playing it requires even more refining. So you have to improve the quality of the guitar and also improve the quality of playing. Next slide is malleable. Malleable means it's capable of changing shape with force. So you can just change the shape by crushing it or heating it. For example, the aluminum is very malleable and can be molded into shapes. You can also just say aluminum, not the aluminum. Aluminum is very malleable and can be molded into shapes. The malleability of rubber is superior to that of stone. That means the ability to change the shape of rubber is easier or better than to change the shape of stone. The malleable child was trained to become a kung fu master. If the child can be taught or changed in any way easily, he or she is more malleable than someone who cannot be taught easily. Now, aluminum is an excellent material for producing cans because it is easily malleable under heat. However, it is an unhealthy metal to the body. And that's true with any food that is packaged with aluminum. Downside. The downside is a bad reason or a possible bad event. So for example, there are significant downside risks to the housing market. That means there could be something bad happening in the housing market, or there is like the prices will go down. If you're talking about markets, downside usually means the price will go down. Or the upside is that bioplastic is biodegradable. The downside is that it is more expensive. So that's the bad reason for using bioplastic. Here's a fish, and the slide says the downside to eating fish for omega-3 oils is the unbearably high level of mercury, heavy metals, radioactive materials, and industrial waste. I do not eat any fish of any kind. It's too toxic. In the old days, maybe, but now I tell everyone forget fish. It's not good. Okay, next one. The debate of bioplastics. There is much interest today in new environmentally friendly plastics. Environmentally friendly materials. Bioplastic is a name for many plastics derived from natural sources. However, there are scores of different byproducts produced from natural materials. Some of these byproducts degrade quickly, while some of them degrade equally slow in comparison to conventional plastic. The reason behind such slow degradation is the fact that conventional plastics can be produced from natural materials. So here's a pretty long paragraph. Basically, we've got this name bioplastic that is a generic name. Generic name for many plastics that are derived or they come from natural sources. But there are scores or many different byproducts which we'll see in 2 slides will be anything produced from something else. Now here's the thing. Some of them degrade quickly. So if let's say these were bioplastic from potato starch, they would disappear in maybe a year if you put it under the ground. But if it's polyethylene like this, it will not degrade quickly because it's conventional plastic that just happens to be made from natural materials. So here it says, even though it is possible to produce polyethylene from sugars, the end result is still a lot of garbage. So even though we're taking sugar and we're making these plastic forks and bowl and plate, they won't disappear quickly. So the problem is still there. The next one explains the word scores. There's really 2 ways we use scores. It's for many or the total. So here's the many example. Scores of people lined up to purchase movie tickets. So if you're many people are lining up to buy these movie tickets, you could also say scores of people. Or there were scores of movies to choose from: action, drama, sci-fi, and even romantic comedy. So that's if there's many movies to choose from. This might be one of these things, but it doesn't matter because I don't care about grammar. Anyway, Ben tracked the scores of all football games on the weekend. So if Ben is tracking the scores, which is the total, of the football games, who won, who lost, maybe he should get a real hobby. Yeah, okay. Scores of buses are lined up at the bus station waiting to take children to school. Or if you're in America, they'll be lining up to slowly rust away because there's no money for the schools to operate. Next slide is byproducts. A byproduct is something that is produced from inputs or not the original material. So if I take a potato and I make plastic, the byproduct is plastic. One byproduct of potato production is potato starch for use in plastics. The byproducts of coal electricity include mercury pollution and smoke. So if we make electricity from coal, it produces mercury pollution and smoke. Those are the byproducts. One of the byproducts of hard work is financial success and positive emotion. If your work, of course, is profitable, lots of organic waste such as leaves and stem cuttings can produce an excellent byproduct for gardening: compost. Compost is very good for gardening. Congratulations, compost. You are successful. Now, it's time for today's fluency practice. Our fluency practice is brought to you by this random picture of a city. The key words are feedstock, catalysts, refining, malleable, downside, scores, and byproduct. Some feedstock materials for the production of bioplastics can include scores of ingredients, but not limited to potato starch, glycerin, sugar, cellulose, bacteria, and ethane. Each ingredient is catalyzed into different products, each leaving different byproducts. Typically, most bioplastics are malleable with heat and pressure. Refining is done with large equipment to produce end products such as kitchen tools, cups, or electronic components. The downside to bioplastic production is the use of valuable food growing space. The upside is reduced oil dependency. So you take your feedstock material, which includes glycerin, sugar, cellulose, bacteria, ethane, and potato starch. You then catalyze it into different products, which makes your byproducts. You can change the shape with heat and pressure. You can also change the shape with large equipment to produce your end products, which are the kitchen tools, cups, electronic components, etc. The problem is that we use our food growing space to produce junk. The good thing is that it reduces our oil dependency. It's time for the questions. Question number 1. What is the downside of bioplastics? A. Cheaper to produce. B. More expensive and uses farmland. Or C. Byproducts are mercury and smoke. Well, the downside, the bad thing of bioplastics, is that it's more expensive and uses farmland. What is an example of refining? Converting ethane into kitchen tools, scores of football games, or practicing singing and improving techniques? Well, this answer has, there's actually two answers. Converting ethane into kitchen tools is refining, and practicing singing to improve technique is also refining. So that was a trick question. Let's go to question number 3. What is a good byproduct of hard work? Money, fat, or hot dog? Well, a good byproduct of hard work would be money. Which is least malleable using heat or fire? A rock, a plastic cup, or aluminum? So what is difficult to change shape using heat? Well, the most difficult to change shape using heat would be a rock. Although you can do it, it's just difficult.